All right. This next question, what is the difference between an atom, a molecule, and a compound? When they talk about an atom, what does that mean? The whole thing of what? One atom is just an element. It's one single element. So like, pick an element. Is zinc just Z or is it Zi? Zn, excuse me. So zinc, an atom of zinc is just one thing of zinc by itself, okay? What does molecule mean?
Molecule is one thing that makes up an atom.
No.
Like the neutrons and protons?
Nope.
Molecules are two of the same elements.
Okay, so more than one atom of the same element. So if we're still using zinc as our example, this would be like zinc 3, or however many. But it's still just zinc, but there's more than one.
So like the hydrogen 2 molecule.
Yes, hydrogen 2 is 2 hydrogens. That is a molecule. And then a compound,
Multiple atoms.
multiple different elements combined, multiple elements combined. Does anybody know any compounds with zinc in them?
Oh, is that like hydrogen, or is that like water? Like H2O?
Yeah, H2O is a compound. Zinc sulfate, do you know what it's?
I'm taking zinc supplements. Does that count?
If it's just zinc, no, because that's a molecule.
I puked orange sludge.
Well,
Is that a G or
a 3. So Tyler said this is zinc sulfate. But it's zinc, sulfur, and oxygen combined together. Okay? Questions about any of those? All right, and then we've got this water molecule. The molecular notation for water is H2O. How many atoms of hydrogen are in one water molecule? 2. How many oxygens? Just 1. What is the number called that tells you that?
there's not in there?
It's an invisible.
There is an invisible one. But these little bottom numbers, what are they called? Close.
Start with a C.
Not a C.
Okay.
They're below, so these are subscripts. The subscript tells you how many atoms. And then if you have more than one atom, that number is the coefficient. We did a lot of, you use coefficients to balance the equations.
Real quick, I have to leave. I was just going to write down one quick, the AMU one.
Well, we have to add it all up, but
Figure it out. I'll just wait tomorrow.
okay. And then to find the molecular mass, we have to account for every atom in the molecule. So, what do you know about the mass of hydrogen? It's what? Yeah. What is the number? 1.008. And in water, what do you know about the hydrogens, Dylan? There are 2 of them, so we need to double that. So what is 1.008 times 2? 2.0 and 6. All right, we also have oxygen. What's the atomic mass of oxygen? 15.999. And how many times are we doing that one? Just once.
So then you add the 2.
Yep, and then we need to add these up to find the total mass for this compound or molecule. 18.015, and then remember the unit for mass, AMU, stands for atomic mass unit. Okay? So if you have to count up all the parts you've got and put them together for that. And then this section, electrons are, we already talked about, small, negatively charged, and they are outside the nucleus, orbiting the nucleus. They have, their orbits have specific number and paths. So Niels Bohr had this theory about the orbits and the levels, so that's why we make Bohr models. So on the next page is room to draw the Bohr model for sodium. In order to draw the Bohr model, what do you need? First of all, what is sodium? How are you going to find sodium on the periodic table? Look for it. What's it look like on the periodic table? What's it called? I mean, its symbol is Na. And where is it at? What's its
First row, third down.
Okay, what's its atomic number? 11. What does that mean about sodium? 11 protons. If this is just neutral sodium, neutral means what? Not positive or negative. So what do you know about the rest of this?
It's just 11 protons.
11 protons. To cancel out the 11 positive parts, you're going to have 11 what?
Neutrons?
Well, electrons. We're going to assume this does also have 11 neutrons because it didn't say it was an isotope. But for this part, I need to draw the electron levels. And if it doesn't have a charge, then there has to be the same number of protons and electrons because they'll cancel each other out. How do you decide where these 11 electrons go?
First one has 2.
All right, our first one can hold 2, so put 2 dots on there.
Second one can hold 8.
Second one can hold 8, so 1, 2, 3, 4, 5, 6, 7, 8. This is going to be 9, 10 total. All right. How many more do we need in the outer level? 1 more to make 11. So first level can hold 2. Second level can hold 8. Third level can also hold up to 8. Thank you. Everybody got the drawing?
The second one can hold 8,
Yep.
and then so can the third one.
Third one can also go up to 8. But you're just going to put as many as you have left in that last level. Okay? So using this picture, we're going to answer these questions. How many total electrons do we have? We already talked about it. 11. What does valence electrons mean? Yeah. The outermost level, we only have 1 out there. Good. Our first 2 levels are full. And then they also want us to draw the Lewis dot diagram. That's supposed to say diagram up there. When you're drawing a dot diagram, what are you using? You're using dots, but what are the dots? No, that was not what we were doing. They're representing electrons. Which electrons? Only the valence. I don't have 11 spots to fill here. I'm only going to do the valence ones for the dot diagram. There's just one. Where's it going to go? Just right at the top. If this was 8, how would you arrange the 8? So what's one of our noble gases? Like if we had argon, yes. Each one, whoops. Each side can have 2 dots, and you want to spread them out as you go around. Okay? All right, the last one on this page. You still writing over there? No? Okay. It's asking about the charge for sodium and the entire first column of your periodic table. So we had this on a worksheet. I don't know if anybody wrote it on your actual periodic table, but go ahead and do that when we talk about it. How do you decide charge? We talked about this when we were talking about bonding. Do you guys remember that? The questions about oxidation. Oxidation levels decide this. I'm going to draw a not great example, but we're going to do it anyway. So we have our first row, helium, lithium, beryllium, nope, not beryllium, sodium, and on and on. Then we have our second row, beryllium, magnesium. If you just want to write this on your actual chart, you can. And then we had our break in here. Then we come over here to boron, just a B, and aluminum, carbon.
Are we supposed to be drawing this?
You can just use your actual chart. You don't have to draw it. Nitrogen and phosphorus. Oxygen, sulfur. Fluorine and chlorine. Helium, neon, and argon. Obviously, your chart keeps going down, but I don't have enough room for that. Your oxidation levels decide, depending on how many protons your element has, that'll decide if it gains or loses electrons when bonding. Okay? The first 1, 2, 3, and 4 are just normal. And then, but once you get past 4, instead of gaining, what do? What? Yeah, they donate their electrons, they lose them. So we're going to count down. So those will be -3, -2, -1. And then our last row is what? Yeah, they're not going to give anyway. They're full. Those noble gases in that last column. What? Yes. So these oxidation levels tell you what their charge would be. Because sodium will have 1 extra proton. So it'll have a positive charge of 1. And make sure you put positive or negative for those. Okay?
So what kind of question will it ask us?
It'll ask you, like, what charge would this have? And you would say 1 positive, or if they're asking for oxygen, 2 negative. But write those numbers at the top of your periodic table so that you have them. Questions about oxidation? All right. Next thing we got are bonds. Don't worry, we're not actually going to do all the bonding we did, but we have 2 types of bonding, ionic and covalent. Ionic is when opposite charges attract, and this usually happens between metal and non-metal. So look at your periodic table. What elements might join as an ionic bond?
Chlorine and there's a bunch of different metals.
Anything to the, so like, they don't even have to just say metal on the table. Anything to the left is considered a metal.
Okay, chlorine and calcium.
So calcium chloride or something like that, CaCl? Sure. Something that's a nonmetal, or a metal, sorry, with a nonmetal. And if you go back to look at your oxidation levels, the metals all had plus 1, 2, 3, or 4, and the nonmetals were minuses. That's why they attract each other. We also talked about covalent bonds. These are when your elements share their electrons.
So oxygen and sulfur. Or does it have to be?
No, it could be oxygen and sulfur. I don't know what that looks like as a formula.
What about nitrogen oxide?
Nitrogen oxide, sure.
Is that
NO2 would be that one. One you're used to seeing a lot. Even though hydrogen is all the way to the left, it's the one exception, it is not a metal.
Because it has 2
It's just, yeah.
special.
It's over there, it's a special one. Okay, so the covalents share, ionic bonds attract. All right, good there? Too far. And then our reactions occur when 2 or more substances combine or break apart or just rearrange. So in this example, which side of this is the reactants? The left side is always your reactant. Reactants. And whatever goes together or breaks apart becomes what?
Doesn't it?
You have the things that you put together and the things you produce, the products. And then these reactions, chemical equations, always have to be balanced. Is this problem up here balanced, and how do you know? So let's check. How do you check to make sure?
You do the dots.
No. I mean, you could do the dots. We did the dots. Okay. Yes. Instead of doing the dots.
I mean, as long as there's 2 lithium,
Yeah, they got to match on both sides.
2 lithium, 2.
Let's see. We have lithium, oxygen, magnesium, and chlorine. Okay. We got to pay attention to the subscripts and the coefficients. So on the left for our reactants, how many lithiums do we have? 2. How many oxygens?
1.
Just 1. Magnesium, just 1. These are invisible ones. And then chlorine is a 2. It matches. For this one, the 2 in front has to be given to both. We're multiplying that, so there's invisible ones down here. But when you do 2 times 1, we have 2 lithiums and 2 chlorines. 1 magnesium, 1 oxygen. And if you go back and check, oops, no, I did. I switched those 2, but it's fine. Chlorine matches. Magnesium matches. Oxygen matches. And lithium matches. So you know a reaction is balanced if the number of reactants equals the products. The same number of each element are in the reactants and the products. So, the same number of each element is in the reactants and the products. Any other questions about balancing equations? Last page of this is what we talked about yesterday. What does the law of conservation of matter say? What do you know about matter? Matter it can't disappear because it can't be, it can be changed, but it cannot be created or destroyed. So it's not going to disappear because I can't destroy it. It's still going to be there. That's a B. Instead, I heard it. It can change it by when we do our chemical reactions, what happens?
Like the temperature can change.
Yeah. It's transformed. We're changing what it looks like. It's moving with something else, being rearranged. So I'll take both of those words. It's transformed or rearranged. How do you spell arranged? Is that right? Are there 2 R's in arranged? Great, we're going with that. So, matter does not disappear. You don't make new matter. It just moves around. Okay? And then the very last thing we talked about yesterday, what is fission? Nope. Fuse together would be not fission. Yep. Separating, dividing, or splitting. Fusion splits the nucleus of an atom, separates it. Fusion combines. So they're opposites. Fission breaks things apart, fusion puts things back together. Any questions about any of this stuff?